All right, you'll find this in your Kirchhoff's experiment, and I wanted to go through this one um, Kirchhoff equation to let you kind of see what's going on here and how we can solve these values here. And now, obviously, these large numbers represent the values of resistors that are in the circuit, and this is the one you're solving in the Nida experiment. So what we're going to do is we're going to take a look first at this loop 1 equation that we have right here. And notice we have an I1 variable and an I2 variable. And part of the um, fun of solving these things is expressing one variable in terms of another. And that just simply means we define I1 or I2 in terms of the other variable. So if we're solving for I1, we're going to express it in terms of I2. If we're solving for I2, we're going to express it in terms of I1. So let's do that. I've written this section right here, up here on the board, and we're going to come up with a value for I1 here. So we're trying to get I1 isolated to one side of the equation or the other, and express I1 in terms of I2. So the very first thing we're going to do, and I'm not going to put every step in here just because I'm having to type this, and you have to be very careful because these I's, let's have caps lock on, there we go. No, I don't. There we go. Y, I do have caps lock on. Okay. Sorry about that. Had a little keyboard trouble, but if you take a look, we've got minus 250,000 I1, and we want to solve for I1, so we're going to express it in terms of I2. What I'm actually going to do is, well, I'll type it just to make it a little more understandable. As I'm going to add 12,000 I2 to this side. And because it's an equation, whatever I do to one side, I have to do to the other. So I'm going to say 12 plus, sorry, I'm typing this on the keyboard. It takes a little bit to make sure I hit the right keys. 12,000 I2. So what we just, in essence, did is, and I can probably recolor, I'll at least bold them. Here, yeah, I can actually recolor them, is I canceled those two out. And also what I just did was click out of my text box, which means I have to create another one, but that's okay. So we'll pop another one in here. So now, because those canceled out, I've got minus, let's go back to black. We've got minus 25,000 I1. Those two cancel out, so that equals 12 plus 12,000 I2. So to get rid of the minus 25,000 in front of I1, that's a multiplier of I1. We're multiplying whatever I1's value is by minus 25,000 there. So to get rid of that, what I'm going to do is I'm going to divide both sides, and I'll put a dividing line here so you can see that. I'm going to divide both sides by minus 25,000. So what this effectively does is gets rid of the minus 25,000 in front of the I1, and leaves I1 all by its little lonesome. But then we have to do the math, and I'm not going to show the math on here, but I'm taking 12 and I'm dividing it by, well, I am going to show the math, but I'm just not going to show the steps. I'm going to say 12 divided by minus 25,000, and that equals minus 0.0048. And because this is a plus, but it's being divided by a minus 25,000, that sign will take on a minus. So we've got to divide 12,000, which is the multiplier in front of I2, by 25,000, minus 25,000. And that's going to give us 0.48 I2. So there we go. We've got I1 expressed in terms of I2. We can't simplify this anymore because we don't know what I2's value is, but we do have I1 defined in terms of I2. So now I'm going to take it also, instead of defining I1 in terms of I2, I'm going to define I2 in terms of I1. And we may not always have to do this, but in this particular case, we did. So I'm going to retype the original equation, 25,000 I1 minus 12,000 I2 equals 12. Sorry, I got the little text thing in the way, but you can see it right over here. So now, instead of what we did before, we're going to be solving for I2. So what I'm going to do is I'm going to say minus 25,000 I1. I did not put a 1 here, so let's fix that. Thankfully I can. You have to be careful because these I's and 1's look a lot alike. Minus 12,000 I2. So since we're trying to solve for I2 in terms of I1, we're going to say plus 25,000 I1 equals 12 plus 25,000 I1. So what we did is we added 25,000 I1 positive to both sides, and what that effectively does is, just like before, negates out having an I1 over here. And it would help if I had checked the color mark. There's color. And there's color. So now we have isolated the variable to one side, and then we've got to start doing some division. So what we effectively end up with is minus 12,000 I1 equals 12 plus 25,000 I1. So now we get to do our division. And we're going to divide both sides by, no surprise here, minus 12,000. So bring down our thing here so we have some room. So if we divide, and what did I do wrong? I did something wrong here. Yep, I put I1 here and it should have been I2. So if you caught that, congratulations. If you didn't, I messed up. But just to kind of take it back where we were, it was minus 25,000 I1 minus 12,000 I2 plus 25,000 I1. The two reds canceled each other out. And when I put the minus 12,000 I2 right here, I wrote I1. So you have to be very, very careful with that, or you can have the same issues I just did, and then everything would be a little crazy. But anyway, we got it right. So this minus 12,000 in front of the I2 is canceled out by dividing it by minus 12,000, which equals 1. So effectively, I2 is equal to 12 plus 25,000 I1. So we've got I1, and I forgot to look up here. How about that? This should be I2. I left it out. So here, and I'm going to change those to a different color. Here are our loop 1 solved equations here, both in terms of I1 and in terms of I2. And we see that I1 is equal to minus 0.0048 minus 0.48. And I did have I2 in there. I thought it was a 12. Like I say, it's easy to get this mixed up. And then I turned around and put it right back in. So I need to get rid of that second I2 there to avoid confusion. And again, I apologize, but trying to type this, whoops, glad we can bring that back. Just trying to find the eraser on this new version of Paint I'm using, and I'm not seeing it, but we can select the brush. If nothing else, there's an eraser. We'll choose white, and we'll get rid of that guy. Well, we got rid of both of them. Well, that was, no, I didn't. Again, that I looks a lot like a 12, and it's not. It is I1. So that's where we have to be careful. So anyway, there is loop 1. Now we're going to come over here and do loop 2 exactly the same way. And I'm going to pause the video and I'm going to put these in and explain, just because it takes a lot of time, but you get the idea of where we're going. So pausing the video. Okay, something to point out here, I had to come back and fix this equation because I say you have to be very systematic. And sure, I forgot to divide the 25,000 by the minus 12,000, which results in the 2.0833 I1. So I had just brought down the full amount without doing the division. So shame on me. Hopefully you caught it and went, why is he doing that? But anyway, here we are. So basically I did the same thing here, wrote the equations from loop 2, this part down here. This represents both. Same equation. Here we're solving for I1. Here we're solving for I3. And we just went through the full steps of adding 12,000 I3 to both sides, dividing by minus 25,000 to isolate I1, and we come out with I1 equals 12 minus 0.0848 I3. And again, that's not 13, that's an I. I wish this particular font had a I with the bars on top and bottom horizontal, but it doesn't, and so that makes it a little more distinguishable if it does. Same thing here, solving in terms of I3, and first thing we had to do was get rid of the I1 on the left side by adding its equivalent positive value. That gave us this right here, minus 12,000 I3. These two canceled out, equals 12, plus 25,000 I1, dividing both by minus 12,000, canceling these out, giving us I3 equals this. Well, if you notice, here's the first thing that came into play. I2 is equal to 12 plus 2.0833 I1. I3 is equal to 12 plus 2.0833 I1. So what we're seeing is I2 and I3 have the same value in terms of I1, which means they're going to be equivalent. So whatever I2 is also the value for I3. Now we hadn't got that far yet, and that's going to be the next step. That's going to be the next video. We're about to run out of time on this one, but all we did was we took the very first loop equation that we solved it in terms of I1 and I2, took the second loop equation that we solved it in terms of these two, and I1 and I3. And notice right here, it says right here, if we subtract I2 from I3, we get 0. So we know that to be true because they're equal. I2 is equal to I3. So if we say something equal to something else, subtract it, we're going to get 0. So we're going to come back, figure out these values in just a moment, and you'll have the answers from there.